I think we're good to go, so I might as well just get started. Welcome. Thank you for coming. I know it's Friday. Yesterday was kind of a long day, and then last night was kind of a long night too, I guess. Anyway, I know that Friday afternoon talks are kind of hard to come, but I do appreciate you coming. As you can probably tell, I'm going to talk about Firebase and serverless stuff, and for a lot of people, that's a bit of a trigger word. I want to start by saying that I'm not here to sell you anything, I promise. I'm not going to be a cheerleader. What this talk is about is exploration. That's what I do for a living. I like to explore, and I like to tell people about it. So there's a lot of stuff in here that you might agree with, might disagree with, and I think all those things are great. My primary objective is that you walk out of here knowing a little bit more than maybe you did before, so that when someone says, serverless, and instead of freaking out, you can have an informed freak out. And that should be a new thing. So everything you're about to see is in a video that I did. That's my website right there. I did a 3-hour video. Everything you're about to see me talk about, I spent lots of time detailing this in this video. I built an e-commerce system, and I decided that if I really wanted to jump into this serverless thing and do Firebase, I wanted to know based on building something. So I built an e-commerce system. And well, I shouldn't say a system. I built like a checkout with a catalog and like fulfillment and digital delivery and the whole deal. So it's actually pretty detailed. I had a good time doing it. And what I'm going to share with you today are 3 main things: successes, which there are plenty of, weird things that kind of caught me off guard, and failure. And I want to just give a shout out to failure right now, because I think it's really important to fail often and to enjoy failing, like John does often. Not really. See, I can't believe I even just said that. I think it just bounced off you and hit me in the head. Anyway, no, failure is one of the best teachers ever. And conversely, success, I will say, and I always say, success is the worst teacher you could possibly have. If you have early success and you're trying to do something, you're going to think you're all that and that you know everything. Well, you haven't failed enough. So failing is good. I tried to fail as much as I possibly could with Firebase. I did. You'll learn about that. But in general, I like Firebase. Came away from this, and I really enjoyed the serverless approach. It made me think completely differently about building applications. So that's what you're going to see today. It took a lot of experimentation to get right, and a lot of exploring the edges and boundaries and breaking things. And so I'll tell you about that. For the snarky out there, I just need to say this, because I know there's snark that's involved with this, but it's also some confusion. Yes, there are servers involved in serverless. It's one of the dumbest names that was ever given to technology. And no, you can't use F# with it. There's my dig at F# that I have to do in every single talk. But maybe actually on Azure you can use F#, so I might have to take that slide off. The best way to think about serverless is you have your application. In a normal circumstance, you'd have an application, and then you'd have a database server, web server. You'd have just servers that do stuff. Well, instead of having those servers that do stuff, you have Google that does stuff. You have a real-time database that Google just manages for you. You have hosting, you have a bunch of things, and it's just Google running your stuff. You don't have to worry about tweaking and tuning and all that other maintenance that goes into running your own box. If you still don't believe me, just get over it, please. And we can move on. It's good to have opinions, but let's have informed opinions. The next question I always get is, have you tried? And that's my job. I like to explore. It's just who I am. And I like to explore new things. So I spent about 3 weeks with AWS Lambda just to see what it was all about. I had a good time doing it, but I spent a lot of time just figuring out the bits and bobs, tweaking little dials with AWS. And I know that people that are familiar with AWS, Amazon's web services, will find that easy. I didn't. I found it confusing and I found it expensive. I got a bill for $50 and I had no idea what it was for until I dug down and found out it was for a networking thing. But anyway, it's okay, it works. And I'm not here to trash it, it's just I'm not an AWS person. Webtask.io is another offering that's out there. It's from the folks at Auth0. And you can go in, open a browser, and write some code using Node and run it. And it's pretty neat. The problem with it is that you pay $9 a month, you get 2 functions, and after that they have an enterprise plan. And so, and they don't even know really what the offering's all about anyway. I have some friends that work there, and I tried to get some answers, and they just kind of shrugged. There's Azure Functions. I worked with that for about 10 minutes, just trying to log in, and I couldn't find my Microsoft password. Next thing I know, I'm answering questions about Xbox, and then I just kind of gave up. Then, of course, Heroku. I think you guys probably know Heroku, where you just kind of push your code into the sky. I've used that many times. Elastic Beanstalk, another Amazon offering. I've used that many times. And then we have Docker and Cloud9. All of these are kind of like these virtual ways of getting around working with a server. And yes, I've worked with all of them. As to why, I just had this inspiration one day. I remember I was in Munich, and I was just thinking, hey, let's build a website without a server. We could try. And at the time, the inspiration was to get a bunch of services to work together, knitted together by either webhooks or something like Zapier, which is a way to compose webhooks together. It's another service. So I decided to work with Firebase, User App, which is now out of business, Snipcart, Sendel, Jekyll, and Shopify was another one. So I put all these things together to see if I could get a working site based on a static website, and I kind of succeeded. There's still a few problems here and there where I realized I just need my own code. And this is where it always comes back to for me is just I've got my shell scripts that will build a node box for me. I've got images up at AWS or Amazon, and I also have images over at DigitalOcean. Just plug and play and go. And it's usually just simpler and easier for me to do that. This was actually no simpler at all and involved a bunch of services that can all fail. So as far as you are concerned, now that you've heard my story, what is this by you? Why would you want to care about any of this stuff? So normally what I like to do in these talks is I like to just come out with it, just come out with a punchline immediately, but I actually have to build the case. So just stay patient with me. What is this going to buy you? Well, number one, this is what I built. And this checkout system is on a static website built with Middleman. I plugged in Stripe checkout, as you saw, and that is a real-time checkout that is being fired by Firebase's database, and all these functions are going off, updating the status, and that status is being rippled back down to the browser. So you can see these little check marks go off when everything happens. Now, you and I are developers, and we don't necessarily, we get excited about this, but customers probably won't care. But then again, they might. Because this is where the thinking starts to change about what's possible with the UI using a real-time backend, having it update your front end. So, for instance, you might want to let the customer know, yeah, we sent you an email, but while they're waiting for the email, give them access to the download. And that's exactly what you just saw. That download button right there actually has counters on it. So every time they click it, it goes up to Google's storage, grabs the file, brings it down with an expiring URL, and updates the ticker right there. I built this with I built it in about 10 days, and it was really fun to do. So overall, in terms of Firebase, what you get with the serverless thing is you get web hosting, number one, which is pretty neat. SSL website, your own domain. You're going to see that in just a second. You get a real-time database that is quite powerful. It's a document database. I kind of think of it more as a key value store. You'll see why in a second. You get authentication. So you can have authentication across mobile and web, and it's all kind of works together, and that includes anonymous authentication, which is fascinating. I'll talk about that more in a minute. You get file storage, so you can allow users to upload and download things. You can put images, zip files, anything you want in there. Mobile analytics, which is a really big deal if you're doing mobile apps. If you've ever done them before and you want good, solid analytics on it, then you know that you usually have to go with a third-party application or service that specializes in mobile analytics, and it's expensive. Google throws it in for free. You get logging, and it's rudimentary. It's not as exciting as Loggly or something like Papertrail, but it works. It works well. And then finally, you get little functions, Firebase functions that fire in the sky based on certain things. So we're going to take a look at all those in detail in a second, but I want to get to the negative part, which is why wouldn't you want to do this? I think that's important to understand when you have to make these decisions as to which technology you're going to use. And the first answer is pretty much the obvious answer, that service lock-in sucks. It doesn't matter what service you're using. It could be Azure, could be AWS, could be Firebase. If you build everything on top of a service like this, then you're setting yourself up for a possible bit of trouble like these people. I don't know if you've ever read this post on Medium. It made the rounds on Hacker News. These poor people, I'm not supposed to laugh when I talk about it. I can't help it. It's hysterical. They do Internet of Things, and so their Internet of Things used Firebase, and they were in the Firebase $25 a month plan, and then all of a sudden Firebase found a bug in the way they reported their analytics that shot their expenses up up to $2,000 a month from $25 a month, which is not funny, I guess. So the poor people tried to talk to Firebase. They submitted a ticket and said, help, what did you guys do? Nothing has changed on our end. And Firebase said, oh, right, yeah, we had to fix an analytics problem that we had. We weren't accounting for SSL certificates coming in through the bandwidth. And so that was enough to shoot this company's bandwidth up, and boom, they're in trouble. So let's talk about this, because this is important. What happened and why did it happen? So this is the pricing model for Firebase, and it's actually pretty comprehensive. The free plan, you can cover most applications with a free plan if you're not using any of the real-time stuff and using just the functions. You can get away with using Firebase for incredibly cheap. If you want predictable pricing, $25 a month gives you access to 2.5 gigabytes of storage, which is a lot of data, and 20 gigabytes of bandwidth per month. To put that in perspective, the entire work of Shakespeare, I think, fits in 5 megabytes, all of it. I ran TechPub business for 5.5 years, and my entire backend database, every bit of data came in at, I want to say 12 megabytes. So you've really, really got to try to hit this if you're just running a regular website. But they also have this flexible plan, pay-as-you-go, which is quite cheap. That's the one I'm on. My last bill was 9 cents. So the takeaway that this company had from this whole problem was sort of profound and sort of not. What they had done was they had built their application on top of Firebase in such a way that they hard-coded just about everything. They were not flexible at all. To fix the problem that was causing this massive amount of bandwidth to go back and forth, to fix it, they would have to recall all their devices and recompile the application and send them back out. Basically, it means going out of business. So they made it in such an inflexible way that they couldn't change. So that's kind of the thing, one, you have to consider. They were sending a ping once a minute from all their devices to Firebase. And when that SSL certificate payload went on top of that, boom. So then you kind of have to scratch your head going, wait a minute. So you relied on a service and you wrote your code in such a way that you couldn't change. Don't we know better than that? And this is where it kind of leads me to my favorite Hawaiian saying, akamai. You hear that a lot over there, and it just means think. Use your head. You know better than this. We're software developers. We should understand this. Now, I can have some sympathy for the developers because they kind of started this as a bit of a fun project, and next thing you know, it's blowing up. But they never went back and tweaked the stuff that they were working on so they could lift up and move. And that was their solution, which is actually kind of misplaced, because if they would have picked up and moved to AWS, they would have been hammered by the bandwidth charge anyway. So looks like they might be going out of business quite soon, no matter what, which is unfortunate. Here's the thing I'm trying to bring across, is that businesses are here to make money. And sometimes if you rely on a service, it doesn't matter what they're doing, and it doesn't matter if it's a platform, it doesn't matter if it's anything. Businesses are trying to make money, and you need to understand how they're trying to make money off of you. And so you have to give yourself a way to get out if you disagree with the way that they're trying to make money. Think about some of your favorite businesses that have come along before. Volkswagen. I loved Volkswagen when I was growing up. Uber. GoDaddy is another one that people are fleeing from. Parse is another horrible story because they were a competitor to Firebase. Real-time backend. Facebook bought them and then shut them down and left a ton of developers in the lurch, and a lot of applications just went offline and disappeared. While you've been here, hopefully you've attended a few talks where they've talked about software architecture. You want to build for change. This is the answer to what happens if Firebase changes its mind in the future. Then you change what you're doing and you don't get caught. That's just the answer. And I love what Martin Fowler says here, that problems and solutions in software have not changed in the last 20 years. All these things are still the same. If you're going to use something like Firebase or AWS or any of this stuff, be prepared to be let down. That's just something you're going to have to do. You have to code defensively, prepare for change. We know this, right? And trust no one. I hope there's some WoW players out here. Trust no one, especially yourself. This is why we write tests. All right, lecture is over. I hope you guys get the idea. That's my answer when people say, I don't know about Firebase. I hear they're kind of questionable. Well, you should be questionable about what you're trying to do anyway. All right, let's get into the fun stuff. Enough of the lecture. How does this actually work, and what does it look like? So the first thing that you're going to do is, of course, you need to have Node on your machine, so it works with Windows or Mac, Linux, whatever. You install Node, and then npm install Firebase tools, and then you install it globally. Now you have the Firebase CLI. You create a directory and then run Firebase init. And that's going to drop some files onto your hard drive. Excuse me, that's going to run this. This is going to run this little wizard, and it's going to first thing it's going to ask you is, what kind of application are you trying to build? What services do you want to use? And so you get database, you get functions, and you get hosting, all or none. You don't have to have each one of them in there. They all work independently of each other, which is really nice. It's then going to open up an authentication screen. You're going to authenticate at Google, and then the browser is going to close, and it's going to drop you back into the command line, where you then get to tell it which project you're going to work against. And so these are little projects that you kick up in the Firebase interface, which you're going to see in a second. So once you're done doing that, it drops a bunch of files in your directory, and this is the fun part. There's not many files there. It is super lightweight and super simple to use. I have two directories here. I have functions. You can guess what goes in there. Inside of there, you can notice that it just looks like it's a node module, and that's exactly what it is. You just export the functions that you want Firebase to run in the cloud, in the serverless space, wherever that is. And there's just simple exports that you would have on a node module. The highlighted directory there is the hosting directory. Any HTML that you have in there is served. Simple enough. They even give you a simple page to get started, and it's got the Firebase stuff in there on your client. There's a few other files in here, including firebase.json, which is just a configuration. It tells the Firebase tooling where to find the database rules, which we'll talk about in a second. And then also, where is the hosting directory? And something I want you to notice is on line 7, even though there's no server, you have server settings. So let's call those serverless settings, but you can set up rewrites if you need to. This is set up to handle a single-page application. So it'll redirect every single request to the app to go straight to index.html. So if users are going to go in there and try and mess with your URLs, they get redirected. Speaking of rules, we're going to talk more about rules in just a second, but one of the things about Firebase is that it's built so that it can be accessed directly by clients. And they did this with mobile in mind. So the idea was that people aren't really going to be able to get in there and mess with it anyway because they're working on a mobile app, but you can also do it from the web. And if this is sounding alarms in your head, I'm going to talk about this in a second, but the idea is that people write directly to your database. So obviously you're going to need some rules surrounding that interaction, and that's what you're seeing here. I'll get into that in just a second. So I'm done. So just simply by running Firebase init, I now have a website that I can use. I now have a database, and I have serverless side server code. So now we can put everything together. The question is, what are we going to build? So I could build a single-page app if I wanted to. I could build a weird hybrid that works with another website, or I could just build a full-on web application, which you're going to see me do in just a second. Personally, I don't think it's very good for single-page applications. I think there's better uses of a single-page application, but whatever you do, it's up to you. And this is where we start making the mental leap. What is it that we're going to build here? This is not just your typical website. What we're building is just another client for the logic that you're going to put up in the cloud. And this is where kind of my brain started to shift a little bit. It's something I've always wanted to do because I like static websites. I really think they're neat. And to have a static website and then my API that has all my logic seems like a great idea. But the thing I don't like about that is the amount of JavaScript I need to support it. This makes it easier working with Firebase, and you'll see what I mean in a second. So my first step here is that I want to create my static site. So for this, I'm using Middleman, which is a Ruby static site generator. It's my favorite, but you can use Hugo. You can use anything you want. So I've installed Middleman here now into the same directory, and it's given me a few more files, including a build directory where it's going to output all the HTML that it generates. So if you're on Windows, Hugo is a good one. If I didn't say that before, is a great static site generator to use. So because I've started to use Middleman now, I need to tell Firebase where it's going to find the hosting files. So instead of the public directory, which I deleted, I am now going to tell it to use the build directory. That's where Middleman's going to put everything when I say Middleman build. It's going to go through all my HTML pages, and it's going to crunch them down. It's going to crunch the JavaScript for me and the CSS, and boom. So this is my website. It is completely static. I don't have to worry about any server stuff behind it, rendering, viewing templates, routes, none of that crap. It's already built, and so it's ready to go, and I can push it live. I don't blame you if right now you're underwhelmed, because what I'm simply talking about is building a static website, and where's the good stuff? Where's the serverless code? The reason I'm starting this way is because you need to have a break in the way you're thinking about building websites and the way JavaScript interacts with a server, because we're going to do something completely different. I have a different client now. That's my website. It's my static site. I want my client to now work with Firebase to do some things. And that's really the start of the different thing that we're going to be doing, the different journey we're going to go on. We have a real-time database at our fingertips. We have authentication for authenticating our users, storage, and HTTP, and all of those fire events. And we're going to use those events to actually do something. So now let's get to it, and we'll step through it. Let's say we have a business where we run tours to Mars, and we're going to send people up to go hiking through the Valles Marineris for $35. First thing that we're going to do is we're going to want to charge them money. And so because we're going serverless, we don't have to use server-side code, and I don't want to write forms and form validation, I'm just going to use Stripe, which is a big payment processor in the United States. I hope you guys are familiar with Stripe. They have a thing called Stripe Checkout, which is just a really cool UI. You just drop it in, fire it up, and off you go. It pops up, takes the payment information, and sends it off. Now, in a normal situation, to try and power a checkout system like this is a normal situation, we would probably have routes like controller, a carts controller, let's say, index, new, create, and so on. So that would be working with carts. We might have something for orders, and then we kind of just process these orders. We bounce Ajax back and forth, wait for the response, and we kind of just sit here and wait for everything to happen. With Firebase, it's different. With what I'm doing, what you're about to see, it's totally different, because we're going to be using 100% events that trigger other events that trigger other events. With the serverless stuff up at Firebase, you get a number of events that you can use. You can trigger a function to go off when you write to a particular area in your database, when somebody authenticates or when they log out. You can trigger an event based on a Google Analytic event, because it's Google. And you can set up a Google Analytics event, and it'll actually fire a function that is in your project. Cloud storage, if someone uploads a file or downloads a file, you can have an event go off. I'm not going to touch on this today, but the Google Cloud system has a pub sub thing, which is amazing. You just pipe data pub sub, you got a message queue behind all of this, and it's a great way to send information between different Firebase projects. So if you like to think in terms of microservices, you can have one project dedicated to what you're seeing here, you can have another one dedicated to fulfillment, and it just sits and listens to pub sub and it starts a chain. The final thing we have is HTTP. Today I'm going to talk mostly about database writes. I'll talk about the HTTP trigger in a second too. But that's how we're actually going to send this checkout information into our serverless back end. Because when the client comes, or when the customer comes and they want to go check out, they're going to fill out our Stripe thing, and what's going to happen is Stripe's going to take that credit card information and send it up to stripe.com. It's not going to touch our servers at all. And they're going to hold that card information, and they're going to give us back a thing called a token. And it's going to come back to us, and it's basically a representation of that card that we can now use to charge against. This is great because it keeps us PCI compliant, which is something we want, meaning that our servers never touch any credit card code, and it's stored safely and securely up at Stripe. What I need to do is I need to take that token now and do something with it, and that's what this code is right here. This is some JavaScript on that same checkout page, and this is the handler for configuring Stripe checkout. And basically, I'm setting some switches saying, yes, I want to know their address and so on. But the big one is on line, I can't see that, line 136, which is the callback handler. This is the function that fires when I get the token back. I'm going to create a payload. The payload's going to have the order items on it. And then I'm going to tack on the payment, which is going to be the token itself. And this is where the goodness comes in. At the very bottom there, that is the Firebase SDK code for writing to the Firebase real-time database. I'll talk more about this in a second, but the thing I want you to focus on is the way I am specifying a reference. And you can think of that as an href for a URL. It's the way that I think about the data that goes into Firebase. It is a JSON document store, but it's also not. It's kind of a key value thing, and I like to think about the data having a URL. And so what I've done here is I've given this data a specific URL of having sales and then an order ID that I create on the client. You can think of it as a GUID if you want. I'll show you that in a second. And then finally, after that, checkout. So Firebase is going to write this data into Firebase directly. This is the Firebase Console, which I haven't showed you yet, but this is the real-time database and what it looks like. As you can see, it looks like just a big JSON tree, and that's all right if you think about it that way. But you can see that what I have is, instead of a big fat GUID, I like more logical order numbers. So I have the name of the store, then I have the date and the time, and then a little bit of randomness after that. And then underneath that, as you can see, I have a bunch of data that goes into the order. What I'm going to do here is I'm going to build out this sale. I'm going to build it out as these events go off. I'm going to tack information onto it as each event goes off. I'm going to build a God document, as they say. And this is where I need to take a quick segue and say that when you're working with Firebase, you really, really have to understand the way they want you to store the data, which is in a flat structure. They don't like big nested documents. The reason why is if you have a big nested document and you pull back at a top level, you pull back a huge payload and you're going to get charged for it. So ideally, what you want to do for speed and other things is to make everything flat with associations. That's really not something I have to worry about because I'm writing historical data. I'm not going to access this stuff a lot. In fact, I'm not even going to use Firebase when I'm done, which I'll show you in a second. Okay, so this is what I'm trying to build out. Moving on, what I need to do now is I need to actually create the function that's going to receive this data. And this is now node code that is running in my functions at Firebase. So what I have here is a database triggered function. And so I'm simply exporting a method in my index.js, in my functions directory. I'm exporting a method. Let's see, what's the name of that one? It's payment received, if you can see it right there on line, God, my eyes are blurry, line 4. That's a simple function I'm exporting, and it's staring at a path, sale, and then parameter, whatever some ID, and then checkout. When something gets written to that path in the database, this function is going to trigger, and it's going to give me an event that I can then use. So from that event, I'm going to pull out the data. I'm just going to grab a value. Now I can do a number of things with the event itself and the data, and I can listen to it for changes and whatnot, but in this case, I'm just going to pull the value out. It's going to be a JSON dump that's going to have the order and the payment information on it. Then I'm pulling out the order ID itself. I am doing that simply by grabbing the parameters from that. I like to call it a URL. It's just like working with Express or ASP.NET MVC. I'm going to pull out that parameter that you see right there. That's my order ID. And then finally, I'm getting a reference. You can think of it as a client. I'm getting a live reference so that I can write data back to that sale if I need to. Something I'm going to just point out really quickly, and I'll talk more about in a second, but notice that I'm calling this, or I'm getting the admin ref. This is important because there's a distinction between what the public can do and what an administrator can do. And since I'm running in a function up on the cloud, I can do administrative stuff, which is like God powers. I'll get to that in a second. So down below, it becomes easy. Now, if I was being a good coder, like I said I should have been before, I would put this all in the lib directory and kind of encapsulate it. But just for clarity, so you could see it all in line, I put it in line here. I'm just requiring Stripe. And then because I can't stand asynchronous code in JavaScript, I'm using the co-library, coroutines, and generator functions with ES6. I'm not going to go into explaining that. But this allows you to use the yield keyword to run asynchronous code essentially synchronously. On line 13, you'll notice that I forgot the yield keyword. Sorry, it's in a later slide. I goofed. But anyway, I'm running the charge. And then down below on line 17, I'm updating the data at the checkout path again. And this time, so I have the checkout data that was just passed to me. This time, I'm writing another key in there called progress. And I'm setting captured to true. So why would I be doing that? Well, let's go back over to the client code again. And this is where I'm using ViewJS. I don't know if you've ever used ViewJS, but it's a fun library. You could use Knockout. You could use any number of things. But View is reactive, and it does this two-way binding. One of the things you can do is to use a plugin called ViewFire, and that allows you to basically listen to Firebase at Firebase, and when something happens, you can change your UI around. It's actually really easy. So here, I'm telling it to listen to our checkout path, but listen to the progress, specifically the progress for that checkout. So that's going to have a bunch of little flags that I'm going to set along the way. By doing that, it's going to allow me to change the CSS and update the screen based on what's happening on the back end at Firebase. So what does that look like? Well, let's run through this order one more time. So we're going to bring up Stripe checkout, and we are going to hit pay. And this is now going to write that record to Firebase in the database. And now a series of events is going off, and each one of those events is updating that progress. And I'm staring at those individual flags in the client, and I'm just changing the CSS as each one goes off. That's that. So what do those functions look like? This is them. I kind of commented them out so you could see what I'm doing, but I want to step through it. And notice that I'm listening to different paths that get triggered on different events. So in the first one, I'm listening for when a transaction is written. That happens when the Stripe charge comes back, and I'm just writing that Stripe charge straight in onto the checkout itself, or onto the sale itself. So when that transaction is written, we're going to write an invoice down, we're going to set the deliverables for the client, and then we're going to set the progress to be fulfilled. After that, we have another function called notification that's going to listen to the invoice key that's happening on that sale. When it sees that an invoice is written, we're good to go to email the client. So we just put a few things together, and we send an email off to the client, and then we're going to put a note on the invoice itself to say, yeah, we emailed you, which is just a nice thing to do. Finally, because I don't trust Firebase, and neither should you, don't ever trust anyone to do anything for you forever, I'm replicating the data completely to Postgres. So this is triggered when the progress gets down to completed. So when the completed thing is written to the database, then I know everything is done, and I can take all that data and write it up to Postgres at compose.com, and I have a full set of data that I can then switch on a dime if I need to and get the hook away from Firebase if they ever decide to charge me $2,000 a month, which I think was Skeet's fault. You're unusually quiet. I do appreciate it. Do you see a problem with the way I put that all together? I told you I was going to talk about successes, which all of that worked, but this is a bad thing that happened to me. So when you write these functions to trigger on events, you're triggering on write, anything that writes to that path. So here I'm listening for an invoice write. So when the invoice gets written, I'm going to email the customer, I'm going to update the progress, we're good so far, but then I'm going to go back to the invoice and say, hey, thanks for that. I'm going to add a note to it. And then I'm going to go up and I'm going to trigger this function again, and then I'm going to email the client. And this happened to me about 5 times. Yeah, this would be a recursive call, emailing your client, blasting them full of spam. That's not a good idea. And I did this about 5 or 6 times, and it was really terrifying to see the logs just going, and like there's no stop button, so I had to redeploy. And I just imagined doing something stupid like that in production. Which leads me to the next thing I was going to say. The production environment is going to be almost completely different from the environment that you have on your desktop. How am I going to possibly replicate this or even know? So that's something that you discover, unfortunately, in the live environment. And hopefully, at some point in the future, this will all change. The second problem that we have, and hopefully people in here are saying, is that a good idea? We're letting the public write to our database. And what I mean by that is my handler is basically writing, and you can see the write code right there. An enterprising young person might sit there, young person, whatever, junior developer, senior developer, neckbeard, anybody could be sitting there, opening their console, what's this guy doing? And start messing around and start writing to our payments table and causing us pain. And this is where you're sitting in a meeting with your boss, and your boss says, wait, let me get this straight. You did what now? And you're like, I'm writing to the database from the browser. Why? You're fired. That's really all that discussion, that's all that discussion needs. So let's talk about security, because that's a big deal. And a lot of people ask that question. How do we prevent bad people from doing bad things? The first way we're going to do this is with rules. So now let's jump in a little bit. How do we protect our data? We've got payment coming in. How do we know that it's good and that we should allow it? So we talked about this, or I talked about this briefly before. Rules are basically just a giant JSON document. And you can set little true-false flags in there, or you can actually have expressions that get evaled when a certain event happens. So let's take a look at that a little bit more in depth. So you set rules for various pathways in your data. So you've already seen that I have a sales pathway. If I had read true on there, then someone in the browser can just use my client and say, show me all sales, and they could have a dump of every single sale in my database. By default, everything is set to read, write, false. As you can see here, I have read, write, false, just to be sure, for the sale. Underneath that, though, I can override that. So the $sign notation there just is like a placeholder. It's like for every single record for every sale that we have under the sales key, we want to make sure that for checkout and payment, that the customer or the client can read the data, because they might want to see the payment. I can set that to false, too. We can allow no reads on that if we wanted. But to write now, we want to use some predefined variables to check, one, is there new data coming in? because this is just on write. That's all this stuff happens is on write. Is there new data coming in? If so, good. We also want to make sure there's no data that already exists. So what we're doing here is we're setting up a condition to make sure that only new writes are allowed, which is just a little bit of extra precaution that we can have so that someone can't come in and tweak their payment data later on or even delete it.
So Rob,
yes?
If I can read my sale, can I read somebody else's sale as well, if I know the ID?
If you know the ID, yes. Not the whole sale. You can read their payment. But that's just a Stripe token. But I'll come back to that in a second. The last thing that we can do here is we can run a validation. The validation just validates some data that is being written to make sure it conforms to certain rules. So here I'm just checking to make sure that there's a token field and there's also an email field. And this kind of works. We can write some decent JavaScript expressions in here to make sure that things happen the way we want. John Skeet just asked, what happens if you can guess an order ID? Yep, you can go in there, and if you know order ID and you know Firebase, you can go in there. If it's set to read, you can read certain bits of information. You have to know the pathway, otherwise Firebase just ignores you. So if you were able to guess those URLs, yes, you can do some damage. The last thing I'm doing here is on the bottom, I'm overriding the progress key so that we can read the progress, but we can't write to it from the client. This is a little confusing when you're starting to do it because what's the difference between validate and write? We have these two expressions that are both running validations, and it's a little confusing. So that confused me. But it turns out that write will cascade to every child record, and validate will only stay with that current node. So that's the difference. But as John pointed out very eloquently, a hole is a hole is a hole is a hole. You're sitting in a meeting with the new CTO that just took over for the old CTO, and they're grilling you about the decisions made on the application. Maybe there was an incident that you're responding to and you're being grilled about it. They will find a way that you screwed up. And if you let the public write to the database, you are in trouble. And that's a problem, and I don't have an answer to it, sort of. And I'll get to that in just a second, because there's actually a way you can expand these rules to do some clever stuff. Let's take a look at option 2, because the first option was just to write to the database. Well, what if we did it the old-fashioned way and just used an HTTP event and just did an Ajax post? And that's certainly something we can do. So here is our different function. Let's call it a different one. Instead of just doing a database write, let's say we did an Ajax post up to our Firebase functions. Once again, I'm in index.js. And here I'm doing functions.https on request. And one thing I want you to notice here is it doesn't care if you're doing a post, put, delete, patch, whatever. It's just going to receive it. And you're getting a request and response object that looks just like Express, doesn't it? In fact, this is based on Express. So you can actually do things that you are familiar with in Node and Express directly here in Firebase Functions, which is neat. So for instance, I'm pulling out the request body, which is going to be the JSON post stuff coming from the payment. It's going to be the items and the payment information. Then I can run an if, checkout is valid, and I could do my validation code on the back end there, and I can go on. Something that's interesting about this that I really, really like is since it's based on Express, you can actually use Express. So here I am just requiring Express. If you've never worked with it, it's the Node.js web framework. I'm requiring Express. I'm creating an application. I'm writing a bunch of routes. I can even use a router if I want. So I can handle all this code in an Express app. This is awesome because if Firebase screws you over in the future, you can just take your Express app and you can move it over to DigitalOcean and just serve that directly. And that's a great way to shield and hide yourself. Because here I'm just passing the app straight off to Firebase Functions, and since it's just like middleware, like what you get when you get a HTTP event, you can just plug it right in and it works, which is kind of nice. But again, a little bit of confusion here. It's based on Express, but it's not Express. It's something a little bit different. So you're missing a few things in here, such as if you wanted to use a view engine and render some templates, res.render does not exist. And I think their thinking on that was, well, this isn't supposed to be a backend for a full-blown website. So you don't get template rendering. You can do it by hand if you want to, but you don't get that. Another one is you don't have access to the raw request body, which kind of sucks because if you're using Stripe and you want to have a webhook receiver, you have to validate using SHA-1 encryption and other things, but using the raw body, and since you don't have access to it, you can't do it, so you have to do a different thing. But those are some of the gotchas that I ran into with that. So again, this is same kind of logic that I have in here in this HTTP responder. I'm going to run the charge and see I remember the yield keyword, which is nice. But here you'll notice that I'm using admin.database.ref. And I wanted to talk a little bit about admin versus the regular Firebase SDK. You can't do administrative stuff through the regular Firebase SDK. They want that separation so you don't accidentally make a mistake based on some authentication or whatever. It's actually an entirely different SDK. It's based on the Firebase SDK, but it's completely different. So you can use that in your node code. You can use it in the back end here at Firebase Functions to do anything you want to the database. Write anywhere you want. You're an administrator. Hooray for you. So that's what I'm using here to then run the updates and write the transaction and so on. The final thing I can do on this HTTP event is I can just write out using CORS, which I have to do because it's cross-origin. So I use CORS middleware, which is just Express middleware, and I write out the response, and we're good to go. OK, so I've managed to change CORS here and move my logic from a database event responder to an HTTP response. Was it worth it? Did I mitigate the problem? I mean, think about the code that you've written that might accept payment. Do you have throttling in there for IP flooding if someone's just going to sit there and write post to it and try and jam up your back end? What kind of validations do you have that you would have written that you can't otherwise write in these JavaScript rules? Well, it's interesting because I found this code on Stack Overflow. This is actually, it's weird. It's a question that Skeet did not answer. No, but this is actually some code that someone wrote that uses another index and anonymous authentication to check a timer to see if it's OK that someone can post again. It's really clever stuff. And it brings me around to saying, highlighting a thing that I really like about Firebase, which is they have a notion of anonymous authentication where it'll actually know who the user is based on a token they stick in local storage. And it's based on IP address and I think MAC address as well. But anytime they come to your site, you recognize who they are. And then you can actually, in your rules here, check the user's ID and then make sure that they're not flooding your system. And if they are, you can cut them off or do other things. So that's actually one really clever way of preventing this. Yeah.
If you're a bad actor, surely you're not going to rely on the auth token that Firebase is putting.
Yeah, John's saying if you're a bad actor, there's ways that you can tweak it. And it's true. Yeah. And like I said, a hole is a hole is a hole, right? So, I mean, you could have some bad things happen to you if you just wrote directly to the database. And just want to say, too, in the video that I did about this, I discussed this, and I go with the HTTP event. OK. So that leads us on to the last part. One thing that we need to do is we actually need to notify our users of what's going on. And this should kind of make you think, well, wait a minute. This is all neat. You're doing the checkout. But what about all the administrative stuff that comes along with the application? That's the hard part, isn't it? You know, you've got to respond to users. You've got to track customers. You've got to know what's going on. You've got to refund if you had to. Well, this is where we get to the really interesting part about going serverless, is you can weave in functions, or excuse me, services that do things. It's all kind of open back there. And there's all of these different ways you can do webhooks and responders to use an external service that might do the stuff you need, such as Drip, which is my favorite email service. I don't think they're marketing themselves very well because they're so much more than just a mail lists or mail automation service like MailChimp. That's what a lot of people think about this company. They allow you to do all kinds of really interesting automations where if you have an email address come in, you can cycle some events, you can update some data. You can do a whole bunch of stuff, including setting up a custom event that gets triggered by an HTTP post. So you can make up your own events on the back end of their system. And here I'm making up what's called a rule. And I'm saying anytime an event is triggered in Drip called new order, this is what I want to happen. So from my functions, all I'm doing is I'm doing an HTTP post. I'm sending some JSON data up. That JSON data has some email. It has the charge information. It has an order ID. So now up here at Drip, what I'm doing is I'm sending the notification email saying, here's your order. And I'm able to use Liquid, the Liquid templating engine that you see somewhere, I think in Jekyll and also on Shopify. And I'm able to format this stuff based on some wildcards and variable data and so on to show a really nice email and send it from my list server instead of writing the mail code myself and the formatting code myself. I'm also doing something else that's kind of interesting. They allow you to have custom fields based on the person's email. So I can come in here and I can set the orders that they've put in there, and I can concatenate them on so I know every single order the person has made. I can also put the charge information, so I can put the transaction IDs for Stripe or PayPal or whatnot. So basically what I can do is if I keep going here, I can make Drip my admin backend, which is kind of funny if you think about it, because if a user comes to me and says, hey, I watched your video, it's really neat, but I want my money back. Sure. I can go to Drip, I can look up their email address, I can see their order, yep, there it is. I can see a timeline of their order activity, and then down below I can see the charge, I can see it was made at Stripe, I go over to Stripe and I refund them based on Stripe's backend because they already wrote it, why do we need to write it again? This works for me because I have a small business. It's probably not going to work for you if you have a big business, but one thing you could do is you could just create a whole other Firebase application, make yourself a single page application that works with this stuff, and off you go. It's just one way of doing it. Why am I doing this? Why would I want to use a service like this instead of just writing my own backend? Well, this is my friend Johnny Wynn. He came in and helped me test out my application that I built. And you can see a timeline there of everything that Johnny has done through this order. You can see down below, at the very beginning, he's triggered the new order event. And then right after that, you can see that some data was set. We have a custom field. The data was set. You can see which order it was. And then you can see that he received and opened the email that I sent him notifying him of his sale, which is kind of cool. I can actually trigger a bunch of other events. If he clicks a link in that email, I can trigger another event that he clicked it, and it can do other stuff like follow up a day later saying, hey, hope the download went okay. So a number of things I can do in here. And then finally, we updated some more custom fields. And if you think about this from a customer perspective and a marketing perspective, your customer doesn't start when the sale is finished. Your customer actually starts way back here when you engage with them on Twitter. Maybe you engaged with them somewhere. They heard about you somewhere, so they became interested in your offering. Maybe they went through a preview thing where they downloaded a preview and you followed up with them with some more marketing emails. But that engagement started back here and then eventually resulted in a sale. You want to know that, and a system like this is built for that. And so that's one reason I love Drip, and I think it's really cool when you start doing serverless stuff and you start thinking about integrating with other businesses. It changes your mind about what's possible, which I really, really like. So much to cover. I haven't even talked about authentication, mostly because it is so basic to implement. It's JavaScript, and you basically wire up 2 calls to Firebase, and they track who the user is when they log in. And if they're logged in, you can wire that straight up to ViewJS, and you can have a little thing show up in the top right corner. You recognize who they are. Welcome back. It's persisted in local storage, so it's like a cookie, but a little bit better and safer. And also, Firebase storage, I haven't talked about, and how it just works just like Amazon's S3. You can set expiring URLs that you can grab from a Firebase function, and you can set it up to be digital download service for your application, which I did. If you want to see more of all that stuff, I encourage you to go to my website, bigmachine.io. And you'll see it, and if you are interested at all, there is a coupon for 20% off. The video is $30, and you can see in detail everything I just walked through. Whew, that's about it. If you have any questions, I'll take them. Thank you. Any questions, anyone? You just shout it out.
Rob.
Yes?
So if I try Firebase on the free plan and I do something stupid where it gets recursive and
Yeah.
I rack up into data, is it going to cut out or am I going to get a bill?
So the question is, if he tried the free plan and he did something stupid, and like something recursive that used up his bandwidth and whatnot, would he be charged? The answer is no. You have to set up a payment plan, you have to put in your credit card, and you have to actively go in there. What they'll do is they'll just cut you. They'll just cut the function off entirely. And you can actually set that rule up, and they have notifications where if you're going over your bandwidth, I didn't mention that, but they do have notifications in there. And you can actually set a switch, like, yep, take me to overage, or no, don't, shut the thing down and send me an email. Yeah? The question is it node only? And, do you know? I was looking that up. I thought I saw some Python code. What's that? Is Python supported too? I think Python, and I think I saw Java in there too. And it's one of those things I I meant to investigate, and the tab is still open in my browser, but I didn't have an answer for you. Sorry. But I think Python and Java are supported. Not F# though. Sorry. I don't want to get in trouble for this. Anybody else? All right. Enjoy the rest of the conference. Thank you for coming. Appreciate it.